A modern commercial airliner typically costs hundreds of millions of dollars. It is designed to fly for decades, carry millions of passengers, and generate revenue for airlines year after year. But sometimes, airplanes that are only a few years old are not repaired, upgraded, or sold to another operator. They are taken apart. Their engines are removed. Their computers, landing gear, and other valuable components are shipped away. And the aircraft itself is eventually reduced to scrap metal. At first, this seems impossible. Why would anyone destroy an airplane that still has decades of potential life left? Why would an airline choose to lose an entire aircraft instead of simply fixing it? And how can the parts inside an airplane become worth more than the airplane itself? The answer has nothing to do with how old the aircraft looks. Behind every commercial flight is a hidden market where engines, spare parts, maintenance capacity, and timing can completely change what an airplane is worth. One example was an Airbus A320neo that had flown for only a few years before it was selected for dismantling. It was not destroyed because the aircraft was too old. It was not destroyed because the airframe had reached the end of its life. Instead, the aviation industry reached a point where keeping the aircraft together was no longer the most valuable option. To understand why, we first need to look at the part of the airplane that became more valuable than the airplane itself: the engines. The aircraft was an Airbus A320neo, one of the newest versions of Airbus's most successful narrow-body aircraft family. The word neo stands for new engine option. Compared with earlier A320 models, the aircraft uses newer generation engines designed to reduce fuel consumption, noise, and emissions. Airlines around the world have ordered thousands of A320neos, and delivery positions for new aircraft can stretch years into the future. This was not an outdated airplane that nobody wanted. Yet some A320neos that were only a few years old ended up being taken apart for parts. One example was N950NK, an A320neo previously operated by Spirit Airlines. Another was N959NK, a similar aircraft that was also selected for disassembly. At the time, these aircraft were among the youngest A320neos ever to enter the aircraft dismantling market. The reason did not begin with the fuselage. It began with the engines. These aircraft were powered by Pratt & Whitney PW1100G geared turbofan engines. The geared turbofan was designed to improve efficiency by allowing the large front fan and the internal turbine to rotate at different speeds. This reduced fuel consumption and noise compared with previous engine generations. But introducing a new engine design also introduced new challenges. In 2023, Pratt & Whitney identified a manufacturing issue involving powder metal components used in some engines. The problem did not mean every affected engine would immediately fail. Instead, it meant that many engines needed additional inspections, repairs, and in some cases earlier than planned removal from aircraft. That created a major problem for airlines. Modern aircraft depend on a huge global maintenance network. An engine cannot simply be removed from an aircraft and repaired anywhere. It requires specialized facilities, trained technicians, approved tools, replacement parts, and detailed maintenance procedures. When hundreds of engines require attention at the same time, repair capacity becomes a bottleneck. Some aircraft were left sitting on the ground for months, not because their airframes were damaged, but because they did not have available engines. For an airline, a parked aircraft creates a difficult situation. It is no longer generating revenue, but it still represents a valuable asset that requires storage, inspections, insurance, and preservation. The longer it remains inactive, the more expensive it becomes to return it to service. At the same time, the missing engines become increasingly valuable. And this is where the economics of the aircraft begin to change. A plane that cannot fly is usually a problem, but a plane carrying two highly valuable engines may represent something very different. It may become a source of parts for the rest of the fleet. Jet engines have always been among the most valuable parts of a commercial aircraft. They are expensive to manufacture, expensive to maintain, and absolutely essential to keeping an airplane in service. But during the recent PW1100G engine shortage, the relationship between the aircraft and its engines became unusual. The engines were no longer just components attached to the airplane. They became scarce assets with their own independent market value. Aviation lessor Aviation estimated that, in some cases, 2 new engines sold separately could represent as much as 80% of the value of a new aircraft. The leasing market showed how extreme this imbalance had become. According to industry data reported in early 2026, the monthly lease rate for a 6-year-old A320neo was around $306,000 in January 2025. A single PW1127G engine could command approximately $200,000 per month. 2 engines could therefore generate around $400,000 per month, more than the aircraft carrying them. This does not mean every aircraft owner could simply remove the engines and immediately make a profit. Engine values depend on many factors, including their condition, remaining operating life, maintenance records, and whether airlines need that specific engine model at that moment. A complete airplane sitting on the ground was less useful than the individual parts needed to return other airplanes to service. That changed the decision facing aircraft owners. The question was no longer only whether the aircraft could fly again. The real calculation became much more complicated. How much would it cost to repair the engines? How long would the aircraft remain unavailable? How much revenue would be lost while it waited? And whether the airplane could create more value if its engines and other components were used elsewhere. For some young aircraft, keeping the airplane intact meant waiting months for repairs and spending more money before it could generate revenue again. Taking it apart released valuable components immediately. Industry data showed that 17 relatively young A320neo family aircraft were dismantled during this period. 14 A320neos, with an average age of about 7.2 years, and 3 A321neos averaging about 6.3 years. These aircraft were not dismantled, because 7 years is the normal lifespan of a modern passenger aircraft. They were dismantled because a temporary shortage changed the value of every major component attached to them. A younger airplane with engines approaching expensive maintenance can be worth less than an older airplane with recently overhauled engines. From the outside, 2 aircraft often look almost identical, but their maintenance records reveal that they are completely different assets. The engines were the main reason these aircraft became candidates for dismantling. But once the decision was made, the rest of the airplane also became valuable inventory. To passengers, an aircraft is one machine. To airlines, leasing companies, and part suppliers, it is a collection of thousands of individual components, each with its own serial number, maintenance history, certification status, and market value. The landing gear can be removed, overhauled, and installed on another aircraft. The auxiliary power unit in the tail can be repaired and reused. Inside the avionics bays are flight computers, communication systems, navigation equipment, and power control units. The wings contain pumps, valves, sensors, and actuators. Even the cabin contains components that may still have value, including seats, emergency equipment, and galley systems. This market is known as used serviceable material, or USM. The word used can be misleading. An aircraft part cannot simply be removed from one airplane and installed into another. Aviation requires complete traceability. The part's identity must be confirmed, its maintenance history must be available, and depending on the component, it may need inspection, testing, repair, or overhaul before it can return to service. In commercial aviation, the paperwork can be almost as important as the physical part itself. A flight computer with no reliable records may have little value, even if it appears undamaged. The same component with complete documentation and approved release records can become valuable inventory. A retired airplane can therefore continue supporting the aviation system long after it stops flying. The image of an excavator crushing a fuselage is the most dramatic part of aircraft disposal, but it is actually the final stage. By that point, most of the valuable parts have already been removed. The process begins with the aircraft's records. Specialists determine which components still have value, which parts have market demand, and which items are approaching maintenance limits. The aircraft is then made safe for disassembly. Fluids, batteries, oxygen systems, and other equipment must be handled according to strict procedures before technicians begin removing valuable components. The engines are usually taken off first because they represent one of the largest sources of remaining value. After that, technicians recover avionics, computers, pumps, valves, actuators, and other parts that can continue operating on other aircraft. The landing gear is removed with careful planning because taking away major structures changes the aircraft balance. Cabin equipment may also be removed, although customized interiors often have less value because another airline may not need the same configuration. Only after the valuable components have been recovered does the aircraft become a recycling project. The remaining structure contains aluminum, steel, copper, titanium, wiring, composites, and other materials. Large sections of the aircraft are cut apart and separated for recycling where possible. Airbus estimates that up to 90% of an aircraft can be eligible for reuse or recycling by weight. But that does not mean 90% becomes another airplane. The empty fuselage shell is often one of the least valuable parts remaining. By the time the cutting equipment arrives, the aircraft has already been financially dismantled. The final step is only removing the structure that no longer has another useful purpose. The destruction of a nearly new aircraft feels wasteful because people naturally see an airplane as one complete machine. But an aircraft's value is not fixed when it leaves the factory. Its value changes depending on what the aviation system needs at that moment. During the PW1100G engine shortage, airlines did not mainly lack A320neo airframes. They lacked serviceable engines and the maintenance capacity required to repair them. That imbalance changed the economics of the entire aircraft. A machine designed to carry passengers became more valuable as a source of components. These cases were unusual. Most commercial aircraft still operate for decades, change operators, enter cargo service, or remain in storage before retirement. A modern passenger aircraft is usually designed around a long service life, and many continue flying long after their original airline has retired them. But the young A320neos showed how quickly the aviation industry can change when one critical part of the supply chain becomes limited. A modern aircraft is not just a machine. It is part of a huge network of manufacturers, maintenance facilities, suppliers, regulators, and operators. Every flight depends on thousands of decisions made far away from the airport. When engines are inspected, where parts are available, which repair facilities have capacity, and whether the economics still make sense. When everything works together, the airplane remains a complete transportation system. But when one critical component becomes scarce, the value of the aircraft can begin to separate into thousands of individual pieces. Sometimes, keeping the airplane together is no longer the best way to preserve its value. Thank you for watching. If this video changed the way you see retired aircraft, please like the video and subscribe to the channel for more stories about how the systems around us actually work. We'll see you in the next video.